A little bit about me. I'm Nash. I'm a part of the DevRel team at Stream, and I'm also a GDE for Flutter. And you can follow me on GitHub or on Twitter using the handle below. So for those of you who are new, here is the quick agenda for today. We're going to look very briefly, we're going to do a TLDR about Flutter for any new people who are in here. We're going to look at some of the problems faced by developers when adapting their desktop applications to, when adapting your mobile applications to web and desktop. We're going to look at some of the traditional ways you would handle pointer interactions in your Flutter application. And of course, we're all here for a talk, so we're going to look at the brand new bleeding edge APIs for solving these problems. So really quickly, why Flutter? Flutter allows developers to build their applications fast and very beautiful. It's a UI toolkit developed by Google, and it originally started out as mobile first, but now supports web and desktop. It's the portable UI toolkit, meaning it also runs on IoT and embedded devices as well. And one of the biggest complaints we hear from developers as to why they're not using Flutter is it's a niche framework. And I'm happy to say that this is no longer the case, since there are companies like Canonical and Toyota that are using Flutter in production at scale. And of course, the biggest selling point for Flutter, in my opinion, is the inclusive and vibrant community. If you've been around programming or if you've been around Flutter for some time, there are lots of great community members out there who write resources and who are always willing to help out and answer any problems that you may encounter. So desktop, web, and mouse. And this is a question that developers are asking themselves as Flutter evolves and adds new platforms. And it presents an interesting set of new challenges for developers. One of them is, how do I add interaction to my application so it feels natural on the platform that it's running on? Now, if you think about a desktop application, one of the common things that users expect is when a mouse hovers over a button, for example, it changes its color, or it changes maybe its elevation, or when the window is resized, the elements and the UI reflows nicely to make use of that space. And for some other types of applications, so for some platforms, there's of course different platform norms. So for example, a window on macOS has different looks and behaviors to a window running on Windows. That's a fun with words there. So one of the worst experiences a user can have is having a scaled up mobile application on a platform and it doesn't respect the platform norms. So for example, if you look at some mobile applications running on iPad, Instagram, for example, it's basically a mobile window that's not really making use of the full screen real estate. It's not really making use of some of the platform norms. And generally, it's not a good experience for the end user. Of course, this could also have the added hindrance of reflecting badly on your brand and doing some damage to your brand. No one wants to use an application that looks kind of ugly, that doesn't really scale well to some devices. So every user, they want to have a really good, really smooth experience when using an application. Now, there are some easy wins. So interactions such as these, such as a hover event, it's really easy to add in Flutter, and it can go a long way to making your desktop feel more native on either on desktop or on web. But how do you actually implement this? What looks really simple could actually be very tedious to implement and scale across a large application. So that's the question that we're going to try to answer in this talk. And to do that, we're going to try building this little UI. And this UI actually has a few things going on with it. For example, when the user hovers over the button, we're going to try changing the color to reflect that, hey, there's some interactivity going on there. And we're also going to increase the border radius of this card to show that, hey, this card is active. Now, for you developers out there, the code for this is actually really, really simple. So we've just got a stateless widget that has some padding. It's using one of the default Flutter widgets, which is card. It's got some presets set for the border radius. and we're delegating part of the UI to private functions. And these private functions are nothing special. So you've got a row with the circle avatar for the image, and we've got a flexible for the name and the content. So how do we start adding interactivity to our application? As a Flutter developer, there's a few things or a few widgets that would come to mind. And one of them would probably be gesture detector. And this is a very common widget for adding user interaction to your application. It provides great methods such as ontap, cancel, drag, pan events, and whatnot. But unfortunately, this does not give us the ability to listen to some mouse events. So for example, if I wanted to listen to a hover, which in the case of our example is what we want to listen to, we can't use a gesture detector. So what else is there? And another widget that Flutter provides is a mouse region, which is you can think of as a more specialized version of gesture detector. So mouse region, if we look at the constructor, actually gives us callbacks for certain mouse events. So whenever the pointer enters, exits, or hovers over the child of this widget, we get a callback that's triggered. And of course, we could also change the cursor, which is a really nice bonus. So let's modify our existing speaker card to implement this. Now, to actually go ahead and implement this, we're going to have to deal with some state. So we're going to have to convert our stateless speaker card into a stateful widget. And here I use the auto generate tool. So command period if you're in VS Code, and convert this to a stateful widget. And of course, we need to tell our widget to keep track of the variables or the attributes we want to change. So in this case, we declare some variables for the border radius and the button color. And like any widget in Flutter, we need to go ahead and we need to wrap our widgets with the mouse region. So here we could wrap our card, and we can implement the callbacks that we care about. In this case, we care about the hover event, which is the border radius that we want to change. And we care about the exit event, and we're going to use that to reset our border radius to a default of 12. So now let's see how this looks. If we hover over here and we come back out, we can see that we've got our border radius is increasing and decreasing as the mouse moves. So that's really great. We're getting somewhere. But now the question is, how do we scale this to our entire application? Or how do we implement this for all of the attributes that we care about? Well, as you can imagine, we need to wrap our button with a mouse region. And very similar to what we did before, we need to implement a hover and on exit methods to change the color of our button. Now, this, as you can imagine, this could get very out of hand if you're implementing this for more complex UIs. So that brings us to like a few standouts with this approach. And the main thing is our stateless widget is now stateful. We're managing a bunch of variables in here. Every attribute, every focus attribute that we want to change, we have to keep track of. Our widget tree is now growing more complex because for every widget that we want to change, we have to wrap it with a mouse region. And the current approach is fine for very simple, isolated use cases, but it can very quickly become difficult to manage across an entire production application. So there has to be a better way to do this, right? Surely the team, as they expand to these new platforms, surely they've thought of a better way to do this. And they have, and that's where material state comes in, or the material state property class, as it's known, comes in. So as the name applies for this, this allows us to change the state or react to state events and update our widgets as interactivity happens. So it's a new way for handling interactivity in our Flutter application. The class itself is basically an interface which defines how the state changes. So it gives us methods and callbacks we can use to change our UI accordingly. And most notably, it has a resolve method, which takes in a list or a set of states and returns some type of value. This value is a T attribute or a generic property, so we can put pretty much anything we want in here. So that's all well and fine, but how does this actually work? And we're going to answer that. So let's dive in here. But before we do, like anything, it's a brand new API, which means things are going to break. There are going to be new widgets that are added. And of course, it's still being implemented throughout the framework. So journey forward with care. So if we look at our existing code, so if we look at the code for our application in an IDE such as IntelliJ, there's something that stands out to you. And no, that is actually not the Flutter outline tool that's broken and causing a strike through in our text. That's actually a sign that our raise button is deprecated. And the reason for that is because we have new APIs that implement this, this property natively within Flutter. So the elevated button becomes is a replacement for the raise button. The flat button is replaced by text button, and so on. Now, if we actually take a peek at how this is implemented under the hood, there are a few things that immediately stands out. For one, the team is hiding some of the hard work behind an abstraction called button style button. And of course, the Flutter team loves their class name, so that just rolls right off the tongue. And they are also encapsulating some of the styling attributes into a class called button style. And if we take a closer look at this, it looks like your generic theming class or your generic style class, except all of the properties are now material state properties. And here you can see they're taking advantage of those generics. So for the text style, they're returning a material state property of type text style, color, and even a double in there for elevation. Now, implementing this and migrating our code to use this is actually easier than you think. So if we replace our raise button with this material button, you can see all we need to do is instead of pass the color directly, we need to use the style attributes. Our color parameter becomes a background color. And the most important thing for the context of this talk is we're using the material state property and we're calling a static function on this, which is called resolve with. And the name of that function kind of gives you a bit of inclination as to what it does. So all it does is basically it provides us with a list of states or a set of states and gives us a way for us to check if the state that we care about is in there and return a value based on that. So for our use case, we want to check if a hover event has occurred and if our button is currently receiving that event. And if that's the case, we want to return the color white. If not, the default color for us is going to be red. So that's basically what we're doing here. Now, you might be thinking, OK, we're using an enum, but what really does it give us? It actually gives us quite a bit of attributes that we can listen to out of the box. So there's hovered, there's focused events, pressed, drag, selected, disabled, and much more. We can actually simplify this implementation a bit more. So if we really wanted to, we could extract that resolve with method into a private function in our class that kind of cleans up our build method. Or we could even subclass the material state or the material state property and implement this behavior in a class. And that's actually what the framework did for some of these more complex or more frequently used properties. So for example, as color, there's a class called material state color that developers can extend on and implement the resolve method within the class, which makes it super easy to share behavior and share colors across your application. So for the context of like theming, for example, you can define a single class that implements this behavior and then reuse that throughout your application. So you're not implementing or dealing with implementing the resolve with method throughout your application, or you're not implementing mouse regions, for example, throughout your application. And if you're curious about this implementation, it's actually really simple. It can be done in a couple of lines. So here you can see we're passing the default color via the super method. And when we actually want to listen to and react to state changes, what we do is we implement the resolve method within the material state color or the material state property class. And this does the exact same thing as a resolve with method. It just does it internally in the class. So if we look at how our code would change, you could kind of see here that instead of calling material state and calling the top level function, we just call we just instantiate the class that we just implemented. So in this case, card button color. Now, this is all really cool, but how do we actually implement this with our own custom widgets? Let's say, for example, you are building your own set of UIs or your own widgets for your application, and you want to add this kind of support to your own widgets. How difficult is this to actually implement? And you'll be surprised. It's actually really, really simple. So together, we're going to hack at some framework code, and we're going to implement this for one of the default Flutter widgets. So let's look at the card widget. This is a widget that we are using in our application, but that does not yet support the material state API. So for us, let's implement and add this add support within the card widget. So some of the attributes that we can add support for are attributes that are changing. So for example, the color, the shadow, the elevation. Basically, we want to identify interactive attributes or attributes that developers or users would want to see some sort of variation in. And that's usually the general practice when you're implementing this type of API. So we're going to follow very closely what the team did with the button style. So we're going to convert our regular variables to material state properties. We're also going to add some type information there via the generic. So we're typing it with color, double, border, etc. And since we're implementing our own flavor, if you will, of the card widget, we can rename this to interactive card so we can easily identify it in our widget tree and it doesn't conflict with the card that's shipped as part of the framework. Now, there's a few things that we should keep in mind when going forward with this. And they are, we need to store, so internally in our interactive card, we need to store the current state or the current list of states for our card. We're going to be using a mixture of different gesture widgets. So for example, we're going to be mixing and matching mouse region and gesture detector. Both are widgets that we discussed earlier. And one of the key things here is helper functions are your best friend when implementing these types of APIs or when implementing code that has a lot of reuse and a lot of common behaviors. So here's a bunch of code on screen, but fear not, we only care about the build method. So if we come down here to mouse region, you can see we're basically just wrapping the default semantics widget from the card implementation with a mouse region, and we're passing it two private methods that we're going to look at earlier. That we're going to look on later. If you remember our implementation from before, the behavior for this is going to be very similar. So, and then the next widget that we're going to be adding in here is a gesture detector to handle on-tap events. So again, we're just going to be using a combination of Flutter widgets in here to handle and give us the effect that we want. And I did say helper functions are your best friend. So here we have the actual state class or the methods that's above the build. And you can see we're doing something very similar. So we're declaring a list of states. And then we've got a method in here that is called update state. And this is used by pretty much every handler. And what it does, it just takes the incoming state and it would either add it or remove it to our internal list of states. And then down here, we're using handlers that would either add a on-pressed event or add a hover event and tell our function whether we should add it to our list or remove it from our list. Now, how do you actually call and resolve this? Well, on our material state, instead of calling resolve with, which is the API we use externally, we're going to call the resolve method, which is an internal API, and pass it our list or our set of states that we declared earlier. And that's about it, actually. That's all it takes to add interactivity to your widgets using material state. Now let's recap the few key takeaways before we actually look at the final code. And the first one is internally, we still need to use gesture widgets to update our state, but it would provide a cleaner external API for developers to use. The resolve with method is called externally, while the resolve method is called internally, and the resolve method takes in a set or a list of states for the widget. And of course, support within the Flutter framework is still ongoing. So there are probably going to be new APIs added, new APIs removed, etc. So how does our final code look? If we look at our code here, there's actually not much that has changed. We removed our card widget that we had before. We removed the mouse region and everything else. And we've just replaced it with our interactive card. And we pass it the card border, which is a class that extends material state as the shape. And of course, for our button, we're using the default elevated button from the Flutter framework. So now we can actually convert our class back to a stateless widget, since we're not really playing around or keeping track of variables in this implementation anymore. Everything is encapsulated in our custom interactive card. And here is a demo of what the final result looks like. So as you can see, you hover over the card, the border radius changes, and if you hover over the button, the color would also change. So thank you all for coming. That's a very brief look at the Material State API. And if you have any questions, feel free to reach out to me on Twitter, and let's keep the conversation going. And if you're building anything with chat or activity feeds, check out Stream. We've been doing some really interesting stuff with Flutter, and our SDKs are open source on GitHub. So thank you all for coming in.